So let's get the derivative of this first.
Notice that you have an x to the fourth and e to the negative x, right? So how many
Yeah,
x terms do you have?
2.
Two, right? And what's going on between them?
Are they multiplying each other out? Or they're
Yeah, they're
one of
being
yeah, they're multiplying
multiplied,
each other.
right? If they're x terms, that means they're functions of x. So then what do you have to, what rule do you have to apply here?
Product rule.
Yeah, fuck.
Yep, okay. So it'd be x to the fourth times e to the negative x times 4x to the third times e to the negative x.
X to the fourth, okay, times what?
X to the fourth times e to the negative x.
What's the derivative of e to the negative x?
Isn't it just e to the negative x again? Or is
What's
that
this? Yeah, what's the setup of this function? How many? Is there any rules you have to apply there?
I thought that the derivative of e was just itself.
Yeah, derivative of e to the x is itself. What's the difference here?
It's e to the negative x.
Yeah,
I'm
so
not sure
then,
how that affects it.
so how many kind of layers do you see in here then?
Layers? What do you mean?
Like a function, like layers, so how many things are affecting the x?
2? The e to
Yeah,
the negative, the e and the to the negative x, obviously.
yeah. So there's the negative x, right? The negative is itself a function, and then e is then e to the something is also a function. So if it's set up like this, what rule do you have to apply?
Oh, do we use chain rule here?
Yeah, it's a composite function, right? Negative x is a function that's plugged into e to the x, so it's a function within a function.
Got it. Okay.
Yeah,
So
so
then that would turn it into e to the negative x times derivative negative x, which is just 1.
what's the derivative of negative x?
Negative 1.
Yeah, -1. Okay, does that make sense?
Yeah.
All right, what's next?
Plus 4x to the third e to the negative x.
Yeah. Okay, and then what do you do once you have the derivative?
Did we set it equal to 0 or set it equal to a number
Yeah,
greater or less than 0?
we set it equal to 0, right? Why did you want to set it equal to 0?
Because that's where the turning point is.
Yeah, that's where the turning points are. So that means that everything in between the critical points have to be either increasing or decreasing. And then we can just figure it out we can just figure out the intervals from there. Okay, so then what do you do from here?
So we'd multiply it out and then add the two terms together. So
Okay.
it's negative x to the fourth times e to the negative x plus just 4 to x to the third e to the negative x.
Okay, yeah, negative x to the 4, he's negative x plus. Okay, so then what do you do from here?
You try to divide out that e, the negative x,
Okay,
or
yeah,
factor it out, sort of.
factor it out. Okay, anything else?
And x squared, x to the third rather.
Yeah, x cubed. All right. And then what's left?
That would give us negative x plus 4
Okay,
equals 0.
right. And what do we figure out here? Oh, you can that one. You can just kind of ignore that. But then,
Okay.
so then, what's the solution then?
So
Yeah,
we'd
this
have
doesn't
that.
really matter.
You flip the signs. Oh, it would positive 4.
Yeah, plug in
Okay,
4,
gotcha.
you get 0, right? And then what
Yeah.
else?
X would be equal to 0 as well because of the x
Okay,
cubed term.
right. So now we have a critical points. Then what can we set up?
Our number line.
Yeah.
Let's see.
Okay, so then what's after that? So like for example, if we want to figure out what's going on um, for x values less than 0, how do we figure? What do we plug in?
Just set x equal to -1.
Yeah, you can plug in some number right in that interval and see what happens. So yeah, what's gonna happen then?
So -1 cubed times -1 plus 4. So that's just -1 cubed is -1 times
Yeah,
3
so negative, right, times what?
times 3.
No,
times 5 times 5.
Yeah, times a positive. So what's it overall?
It's gonna be negative.
Yeah. So what does it tell you then about the function?
It is decreasing from -infinity to 0.
Yeah, exactly. Since it's a negative derivative, the function is decreasing in that interval. Okay, what's next then?
Set it between 0 and 4, so we could just do 1.
Okay.
And that would be positive.
Yeah. Yeah, it's negative.
Yeah, if we set it equal to 5.
Negative in front. Yeah.
Yeah.
It's the positive times negative, right? Okay, yeah, and that tells us, okay, so we know which the intervals that are increasing, decreasing, and then what about the local maxes and minimums? What does 0 and 4 tell you?
The turning points of the function.
Yeah, and what else does that mean then? Or the turning points? Yeah, increasing, decreasing. So then how else do you interpret the turning points?
Maxes and mins.
Yeah, those are where the maximum mins are, right? So how do you figure out the actual values of the maximums and minimums?
Plug in 0 to the original function and plug in 4 to the original function.
Yeah, exactly, because those give you the actual values of the function.
Okay, got it.
Maxes and mins.
So I have to use. So for 0, it'd just be anything to 0 is 1, and 0 to the 4 is just 0. So it'd just be 1.
Well, what's 0 to the 4th?
0. Oh, so it's all 0.
Yeah.
Okay.
Okay, so that's 0. Is that a max or a min?
That would be a minimum.
Yeah, it's going down then up. Okay, and then what happens when you plug in 4?
4 to the 4th is that. I'm getting 4.688, 689.
Okay, some positive number, but this is the exact number. So then is this a minimum or a maximum?
That would be a maximum.
Okay, yeah. Okay, that should be it then.